Hello and welcome to the second video of the module 4. In this video, I am going to explain the problems based on the D'Alembert's ratio test and Cauchy's root test. Test the convergence of the series 2 factorial by 3 plus 3 factorial by 3 square plus 4 factorial by 3 power 3 plus etc. So here the un will be n plus 1 divided by 3 power n and un plus 1 will be n plus 2 factorial divided by 3 to the power of n plus 1. Now let us consider un plus 1 divided by un. That will be n plus 2 factorial divided by 3 power n plus 1 into 3 power n divided by n plus 1 the factorial. Now we'll cancel it by writing n plus 2 factorial as n plus 2 into n plus 1 factorial and 3 power n plus 1 as 3 power n into 3. Cancelling 3 power n and 3 power n and also n plus 1 factorial and n plus 1 factorial, we get un plus 1 divided by un as n plus 2 divided by 3. Now, in order to test whether it is a convergence or divergent, we need to take the limit as n tends to infinity and check for the value. Let us take the limit as n tends to infinity. Un plus 1 by un is equal to limit as n tends to infinity n plus 2 divided by 3. When we put n is equals to infinity, we will get infinity and which is greater than 1. Therefore, by D'Alembert's ratio test, the un is divergent. Next, let us see the Cauchy's root test. If summation an is a positive term series such that limit as n tends to infinity an to the power of 1 by n is equal to L, then the series converges if L is less than 1, diverges if L is greater than 1, and the test fails if L is equal to 1. So this is all about the Cauchy's root test. Now let us solve some problems based on this. First problem. Test the convergence of the series summation n by n plus 1 to the power of n square. So an is given by n by n plus 1 to the power of n square. Now let us raise both the sides as nth root or to the power 1 by n. That is an to the power of 1 by n is equal to n by n plus 1 the whole to the power of n square to the power of 1 by n. Thus cancelling the powers, we get n divided by n plus 1 to the power of n. Simplify by taking the n outside from both numerator and denominator, we get an to the power of 1 by n is equal to 1 divided by 1 plus 1 by n whole power n. Let us take the limit on both the sides. An to the power of n plus 1 by n is equal to limit n tends to infinity 1 divided by 1 plus 1 by n to the power of n. And we know that by using the formula, the denominator will be equal to e. So 1 divided by e is lesser than 1. Hence, by the Cauchy's root test, the given series is convergent. Let us see another problem. Examine the convergence of the series summation 1 plus 1 by n to the power of n square. So, an is given by 1 plus 1 by n to the power of n square Now let us raise to the power of 1 by n on both the sides. Then we get a n to the power of 1 by n is 1 plus 1 by n to the power of n square whole to the power of 1 by n. When we simplify this, a n to the power of 1 by n will be equal to 1 plus 1 by n to the power of n. Take the limit as n tends to infinity on both the sides. Then we get limit as n tends to infinity, a n to the power of 1 by n is equal to limit as n tends to infinity 1 plus 1 by n to the power of n. That will be equal to e, and we know that the value of e is certainly greater than 1. Therefore, by the Cauchy's root test, the given series is divergent. Thank you.